systems. And I'll be your host for today's webinar. Please note that this session is being recorded and uploaded on the YouTube channel where it will remain accessible. I would recommend you all to check the FOE community channel where you will find the recording. Also, keep in mind that the link to attendance sheet will be provided only at the very end of this session, and attendance to all three webinars are mandatory in order to be eligible for certificates. I will also send the link to the Google Classroom one last time in case you've missed it during the previous sessions. It is imperative you join now, as you will need to send your project brief in few days on the platform. In addition, we post additional content on it, so feel free to use all resources available. So as you may know by now, the main principle of this competition is based on the use of Arduino IoT in the agricultural field. And no fear for people not in the technical field, as you can always submit your proposal and stand a chance to come forward and implement in our electronic lab your projects. Doing so, you will need a team of maximum 3 members and need to start your design ASAP, as the deadline for submission is on the 22nd of October. Your proposal will be thoroughly examined by a panel of judges, and if your designs are in the top 8, you will be hence selected to come on implementation day in the engineering tower on the 26th and 27th of October, and then present us your projects on the 28th of October. Top 3 will then be rewarded with very interesting awards, so stay tuned for that. Also note that at the very end of this webinar, very important details about the competition will be communicated to you. Now, before we start this session, I have the pleasure to introduce Ms. Pooja Sinod, the Youth Ambassador of Regeneration Mauritius, whose work involves promotion of local consumption and emphasis on local underutilized crops. She was the national winner of Fame Lab 2021 and the first-class gold medalist student in BSc in Food Science and Technology, minor Food Entrepreneurship. Ms. Sinod, the floor is yours. We can't hear you.
C'est un problème avec le microphone.
Can you hear me now?
Yes, I say okay.
Okay.
Yeah, now it's okay.
Yes, okay. Yes, so good evening, everyone. Thank you, Nimai and Hemkesh, for organizing such an interesting training program. So like it has been mentioned, I'm the Youth Ambassador of Regeneration Mauritius. And this role has been created to kind of give the youth a platform to voice out their ideas, concerns, and views, and also to build the youth community by bringing together students from universities, colleges, schools, and young agri-entrepreneurs to take collective sustainable actions to regenerate our Mauritian food system. So in March 2022, Regeneration Mauritius launched its first OM talk, which was the Agriculture by the Next Gen, when we started the discussion about the role of youth in agriculture in Mauritius. And I also invited Yashil, who is the faculty representative of engineering, and he talked a bit about the scope of IoT in agriculture in the local context. So since then, I have been actively engaging with the Faculty of Engineering, Dr. Guru Chen, and the Faculty of Agriculture to kind of create that synergy. And recently, on the 16th of September, I organized an event on career and opportunities in the 21st agro-value chain at the University of Mauritius. So this event was a result of collaboration amongst two of the infrastructure partners, namely Catapult Mauritius and the University of Mauritius, who works together through the platform that Regeneration Mauritius facilitates. So what we've seen that the students of FOE, FOA, and FYCDT were invited. And it was very interesting to hear from them, irrespective of their field of study, that they feel very concerned about the global challenge of the food security and climate change. And most importantly, what impressed me, that even if they did not come from the Faculty of Agriculture, mostly from engineering and FYCDT, they showed their willingness to be part of the solution to save the future generation. And what this event also demonstrated as the outcome is that, yes, the food system is indeed very complex, but we don't only need people with agricultural or food science background. So there is this very need to work in synergy with engineers and also IT people to make those real changes in the 21st agro value chain, which I believe is a brilliant follow-up example of today's and the 3 days training program on smart farming. And also to sustain that, the theme for World Food Day 2022 is which was held on last Sunday, on the 16th of October, is to leave no one behind, which again shows the inclusion today in the audience present. So I think kudos to the organizing team. And I hope that at the end of today's final session, you guys will have a lot of new insights and inspiration for the way we see the future of farming, agriculture, and the food system in general, with the help of those data-driven technologies that has been taught to you throughout this course. So yes, I think on my side, that's enough. But then if you do want to join the Regeneration Mauritius Committee, so please, to let your voice be heard, please join on regeneration.mu. And thank you.
Thank you very much, Ms. Pooja. I think that leaving no one behind is a very important principle to adopt in life. Well, thank you very much for your approach. Now, without further delay, with utmost honor, let me present to you today's speaker, Mr. Navendra Budia, a senior lecturer at the Faculty of Agriculture at the University of Mauritius. His field of expertise is in climate smart agricultural operations for sustainable horticulture. He has also worked as agricultural consultant for local and international organizations such as FAO, UNDP, European Union, amongst others. I will now hand over to you, Mr. Budia.
Thank you, Sanya. I hope you can see me and hear me clearly first.
Yes, we can.
Great. Okay, good evening, everyone. Good evening, dear students. So a great pleasure to listen to Pooja, our ex-student of the faculty. And I also thank Mr. Kalisa and Mr. Hemkesh to get in touch with me. Thank you for the invitation and the opportunity to share the little I know with you on smart farming. So without any further delay, I will start sharing my screen. Is that fine? Just one volunteer, just to know the screen is correct?
Yes, all good.
Excellent. Okay, so the talk of tonight is about farming systems and agroclimatic requirements for smart farming. In fact, when we talk about agroclimatic requirements, we'll be talking about factors in agriculture. And when we talk about factors, we also need to talk about parameters. It's really a long one, because I have tried to merge like 10 to 15 lectures into a single talk. So please bear with me. And if possible, I will skip a few slides just to save time. here's a roadmap of my presentation. So initially, I will talk about farming systems. I will start with the current one that is adopted locally, and the emerging farming systems will follow. We'll have a talk about the crop needs requirements and about the parameters, and we'll end with some concluding remarks and takeaway lessons. Now, just to show you on the photo, we have a container farm. Maybe many of you don't know they exist. Yeah, container farms do exist, and even in Mauritius, we have 5 container farms that are being, being tried and being evaluated under local condition. And in the photo bottom right, so that's the inside of a container farm. Just to tell you about container farming. I will start with a saying: the first wealth is health. And when we talk about health, we talk about human health first, of course, okay? But that human health, it comes from plant health, from soil health. Now, I chose this saying because it is very important for us to understand that healthy human life emancipates from healthy plants and soils. Next, I will share a couple of statistics. Current population, global population, 7.7 billion. That will grow by another 2 billion in the next 30 years and will reach around 9.7 billion people by 2050, according to UN. So in the coming 3 decades, we'll need to produce up to 70% more food to keep up with the demand, to provide food to the global population. Okay. And we have to bear in mind that we can't increase the area of agricultural land. Maximum percent that we can increase area of agricultural land globally is by 5%. So there is no choice. There is no other alternative than being more productive, being more efficient. And how we'll do that is by intensification. And that intensification, it has to be sustainable. So here is where we have to get our brains, politicians, engineers, the community at large, stakeholders, farmers, many others. We all have to take responsibility to intensify that production for a sustainable future, for a sustainable world. And it was possible with the use of, electronics in agriculture, iFarming. For example, from a case study in Tunisia and in France, by using iFarming, there's a lot of e-agriculture, connected agriculture, they have been able to use less water by 40%. Even when they are using less water, they have been able to increase productivity by 30%. So there is this possibility of intensifying, saving resources, and producing more. Next, when we talk about smart farming, it is somehow related to connected agriculture. Now, connected agriculture, it's a market of around 3.35 billion USD. That was in 2019. And that is forecasted to grow up to 7 billion USD by 2025. So there is a growing market for that connected agriculture. And let's not forget that IoT, Internet of Things, is a significant part of that connected farming. So this is our driving force. We know there is a future for that. And the world is moving in that direction. If you see how many buildings have been converted into vertical farms, you see how many containers where we sea freight goods have been converted to farms. It's really very promising for this sector. So I will try to connect to the previous speaker in 3 slides, IoT for precision agriculture and smart farming. Now, the philosophy here is about increasing efficiency. Efficiency at farm level, be it site-specific or otherwise, we are concerned about efficiency. Why efficiency? We want to be more productive. We want to be to increase farmers' profits, and yet we want to minimize internet impacts on the environment. We don't want to cause harm to the environment. That's why we are talking about climate smart agriculture. We are talking about regeneration agriculture. We are talking about smart organic farming. There are so many farming systems that have come up to care for the environment. So the whole idea about using IoTs is about saving resources. This is my perspective from agriculture. Save resources, reduce costs, cut down costs, increase profitability, increase efficiency. Okay, so that in the same area, with less resources, we can produce more. One particular application of IoT in agriculture is a site-specific crop management system. So this is a form of precision agriculture. PA is precision agriculture, whereby decisions on resource application and agronomic practices are improved. So we are making better use of resources, and we are improving agricultural practices, and we are meeting, the needs of soil and crops. The next slide, like I said, I want to connect to previous speaker. You know about it, the smart and digital agricultural architecture. Okay, so on my side, I operate more on the first column, where we talk about sensors, microcontroller boards, these sort of things. Okay, so I am a plant scientist. I work with plants. Around my plants, I can have sensors to take measurements, which I can send to a cloud, I can send to other digital devices, and so on. So this is where I operate. Now, it's good that I mentioned that we at the Faculty of Agriculture, we have a project joined with FOICDT, whereby we have funding from EU to work on sensors. And the sensors that we are targeting is a soil moisture sensor. So we want to work on something related to irrigation, and we want to cut down the amount of water used. We want to save agricultural water by the use of sensors. So we have a collaborating team in another faculty working with us on this area. Now, the other three columns where we talk about communication protocols, cloud platform, analytics, it's more in your area. You are mostly people from the engineering or the ICT sector. Okay, so where you are more, talking about machine learning, artificial intelligence, and different cloud platforms. And another column where I come into play, I can come into play as an end user. Okay, as a researcher, as an academic, as a student, as a normal consumer, so where I can have access to mobile applications and also access to website. Okay, so that's the architecture that we have been talking about. So sensors. So when it comes to sensors, we have many different types of sensors. How a person like me in agriculture can help? I can help to decide on which sensor you will go for this project. Okay, then you will install the sensors on your board, and then it will come a time where you have to calibrate it. Now, to calibrate it, you need values. Again, I come into play and give you the parameters, give you the range of values for different parameters. Okay, so this is how I interact with people from the information sector and from, the ICT sector and from the engineering sector. So you have many sensors, okay? Just to mention a few: carbon dioxide level sensor, relative humidity, light intensity, soil moisture, where we are dealing, temperature, pH, EC is electrical conductivity, dissolved oxygen, NPK sensor. All these exist now, okay? And I understand that you people would be more, you will be working more on Arduino, which is very good. And you have very nice, how to say, information like pamphlets that are posted on website, which you can download. You have certain apps that you can download. and you have very user-friendly YouTubes, well explained how to connect sensors, how to use them, and so on. It's very nice. I have seen them. So this is a little bit about goal setting and how I connect to previous scientists. So now I will have a brief expose on different farming systems. So the first one that I will tackle is hydroponics, or what we call soilless culture. So why we call it soilless culture? Because we are growing without the use of soil, what we call culture au sol. Now, at this point, we need to differentiate this soilless culture from sheltered farming. Okay, so there is another subject where we call it greenhouse management. We call it production sous serre. So that's a bit different. So that's about the aerial environment of the plant. Okay, so sous serre, c'est aerial environment of the plant. Here, when we talk about culture au sol, it's more about the root environment of the plant. Okay? And let me tell you, with hydroponics, technically speaking, you can grow any crop. You can grow any crop, technically speaking, in hydroponics. But from an economic point of view, when we talk about cost of production, when we talk about profit, then we go for a selected number of crops. Why a selected number of crops? Because of profitability. Let me take an example. You can grow rice and wheat under hydroponics. They do it in labs. But commercially, it is not viable to grow rice and wheat in hydroponics. If you do, how much you will sell the rice and the wheat per pound? Okay, so that's a very important point. So we go mostly for high value crops when we talk about hydroponics. Even when we talk about, innovative farming systems like vertical farming, container farming, aquaponics, and so on, we go for high value crops. So that will help you a little bit when you put your project in context. Very quick definition of hydroponics. Technology for growing plants using a complete nutrient solution. And I will explain what is a complete nutrient solution in detail today. For now, a nutrient solution is just water, tap water, plus mineral nutrients. There are many minerals in there. Now, when we use a nutrient solution, we can use it with a substrate, for example, coco peat, La Paille Coco, or without a substrate. If you grow without a substrate, then basically you are growing in water. Okay, so from here, you can understand that you have basically two systems to start with. Substrate culture system, where you use coco peat, a soilless substrate, you don't have soil there, or water culture system. I'm sure you have read about it and you know about substrate culture and water culture. So different types of soilless culture. Aeroponics, a system in itself, aquaponics, another one. Then under hydroponics, we have substrate culture and water culture. Now, when we take substrate culture, we have different methods under substrate culture. Okay, I won't have a slide on it, just to give you example of substrate culture. Here you have a substrate called coir. So it is peat culture. You can have sand culture. Okay. You can have gravel culture. So you have different methods under substrate culture. You can use all these substrates. But in Mauritius, coir, coco peat, is most popular. In fact, this is the most common hydroponic system in Mauritius, using coco peat. Now, next is water culture system. Water culture system, there is no substrate. You are using just water and minerals. Okay, like here you have an NFT system. I will define it in a short while. Okay, in this slide, I give more information about substrate culture. When we do substrate culture, the plants are grown in an inert medium, not soil. And the inert medium is fertigated by the nutrient solution that I spoke about. Water and minerals are supplied or distributed using irrigation pipes and spaghetti tubes to the plants. As simple as that. Water culture, you have here a diagram to illustrate water culture. You have the plants. Here the plants are on a floating raft, for example, polystyrene. Okay, so in the polystyrene, you have holes holding the net cups. The net cups hold rock wool, and rock wool is a substrate where the plant is growing in. Okay, so plant, rock wool, net cup, they float on a polystyrene, and the polystyrene float on water. The water is in a tank. Here, for example, it is a deep water culture. Now, it is very important now. What else is important apart from water and minerals? Temperature is important. Aeration is important. So that's why you have an air pump, you have an airline, you have an air stone, so that we can aerate the water. If you don't aerate the water, the roots will die, and later they will get a lot of infection and diseases. Okay. So here is a system where the roots are immersed in water. The water contains minerals, what we call nutrients. Okay. Water and nutrients make the nutrient solution, and the nutrient solution is aerated. So oxygen level is very important in this system. And also you will have to monitor carbon dioxide level. Very simple, put it very simple. Now, methods of water culture. I will talk about two methods. Nutrient film technique. I have a separate slide on it. I just expanded it so that you can see the diagram clearly, a bit similar. But here you see that the roots are in contact with a thin film of water. It's only a thin film of water that is running down the growing tree or trough. Okay. Now, that thin film of water contains minerals and it is aerated. It should have a desirable temperature to start with. Later, we'll add more parameters. Okay. So in NFT, you have a sloping light-proof channel, a growing trough if you want. Okay. A continuous flow of nutrient-rich water, and the water is aerated. So the water flows down the channel. It is collected. It is sent back to the tank of nutrient solution, which is pumped again to the system. So it is a recirculating system. We don't waste water. Water is being recirculated. Okay, so we have optimal use of water and optimal use of minerals as well. Okay, so don't forget that the roots here, they grow in a very shallow nutrient solution, which keep on moving, circulating nutrient solution. Next one, which I mentioned, deep water culture. Here, the roots are suspended in nutrient solution, and the nutrient solution is aerated. So basically, we can change the water, maybe twice a week. We can change the water. We just move it from this tank to another tank. Okay, this can be done. But basically, we see that for a couple of days or 1 to 3 days, the water is likely to be stagnant. Okay, and that water is quite deep. I would say 30 to 40 centimeters. That's the depth of typical deep water culture system. Okay. Now, how the nutrient film technique operate? Why I'm laying emphasis on nutrient film technique? Because this is a kind of farming system that you can use and you can easily automate it. We do have application of IoT in such a system. And it can be easily done at model level and even at proof of concept level. You can easily, explain it. Okay. So our channel, again, water with minerals are dropped in here. This is a entry level for the nutrient solution, and the nutrient solution will move down the channel, which is sloping downward. Okay. Now the water will drain and go to the nutrient solution tank. Okay. Now the plants are grown in net cups. The roots are in contact with a thin film of nutrient solution. Okay, so the nutrient solution will provide the plant water, minerals, adequate temperature, and we'll take other factors in a few minutes. Now, whatever nutrients have not been absorbed, whatever minerals have not been absorbed, they are returned back to the tank. And from the tank, they are going to be pumped back to the system. So there is somehow some power consumption here. But today, with technology, we do have pumps that can be operated by PV, solar panels. So that's another idea where you can add your technology. You can think about how to merge, how to integrate sensors when operating, these PV operated pumps. Okay, for example, you can have timers. You can reduce the time that you use the pumps, so you save your battery power. So all these are ideas that you can take up and you can build good quality proof of concept. Now, this is a smart NFT system. So it's a proof of concept. Basically, I just got it on the internet. I'm thankful to the guy who did it. So this is your NFT system. And you have, several kind of sensors that are involved there. They are going to sense EC, pH, temperature, etc., etc. And they are going to activate, other devices that are going to control the water parameters and give optimum conditions for the plant to grow healthily. So this is a little bit about hydroponics and NFT. Now you would like to know what can we use in a system of hydroponics. Again, in simple terms, when we talk about hydroponics, we have two concentrated solutions. When we talk about hydroponics, two concentrated solutions. Concentrated solution A contains these straight fertilizers: potassium nitrate, monoammonium phosphate, magnesium sulfate, potassium sulfate, okay, and monopotassium phosphate. Okay, that's concentrated solution A. And then you have another solution, okay, where you have different salts. One salt can repeat because it is required in large amount. Potassium and nitrate are required in very huge amount. So that's why they are in two different concentrated solutions. So in solution B, apart from KNO3, you have calcium nitrate and you have all the trace elements. Well, I'm going to explain these minerals in coming minutes. Okay, so that's a simple model, and it just shows you the different fertilizers that you can use. And the fertilizers contain all these nutrients here. I won't go into detail here. Just what I want to convey to you, whatever nutrient I will explain in the second part of my presentation is present in the solution. And the concentration is given. Now, two very important points. When we prepare the nutrient solution, we have to bear in mind the stage of growth of the plant, okay, and the species. This solution here in the upper part, I have clicked it. So in the upper part, that's the composition for tomato at an early stage of growth. It's written tomato starter. Okay, so that's one stage of growth, and it is specific to tomato. Okay, now when the crop grows in height, the demand is greater. When the plant becomes bigger, they need more nutrients. Okay, so you will see in the finisher solution, the concentration of the nutrients will change. Okay, so we'll have to bear in mind that agriculture, it's not the black box concept, because it's very complex. We have to look at many things at a time. Okay, so stage of growth, variety, crop species, all these. That's why it's a subject in itself, because we have to learn it case to case. Okay, we can't really generalize. Okay, so in terms of water quality for hydroponics, we are interested in measuring pH, degree of acidity and alkalinity, measuring electrical conductivity, measuring the level of different minerals like NPK. You have heard about NPK, nitrogen, phosphorus, potassium. You have calcium, magnesium, sulfur. So you have certain minerals. We need to know about salinity. Salinity is about sodium chloride content. We need to know about alkalinity. It's a term that is measured differently. Also, pH can indicate to us that it is alkaline, but we need this alkalinity value to bring certain correction in the pH of the wood. Whether you have biotic organisms, fungi, bacteria, etc., whether you have residues, you have toxic elements, so we need to measure all these parameters. Next farming system, okay, is aquaponics. And what is aquaponics? It's a hybrid between aquaculture and hydroponics. Now, long ago, people were doing aquaculture. The problem is, what do they do with the wastewater? After fish culture, they have wastewater. What do they do with it? It contains a lot of minerals. And if you dump it to the soil, it is going to cause pollution. It has, for example, high level of phosphate, high level of nitrogen. You dump it in the ground, it will go to water tables, it will go to rivers, lagoons, and other water bodies. You will have algal bloom. It is going to cause damage to the aquatic ecosystem. So some 20, 30 years back, so people have come up with the idea, why not use this water to grow plants? Because you have minerals that plant needs. So hence, the term aquaponics became popular some 20, 30 years ago. But in history, it was something that was used several centuries back by the Chinese. And they were using it without knowing they were doing aquaponics. Okay, so I won't go into the history, but just to tell you the hybrid between the two. Now, when we talk about aquaculture, water quality is very important. And some parameters there, temperature, pH, EC, and don't worry, you do have sensors on Arduino, you do have sensors for these. You even have sensors for NPK. So all these sensors are available. So it's now up to you with your innovative ideas, with your creativity, what sensors you're going to bring to build your board, okay? So and make like an integrated system to do smart farming. Now for hydroponics, again, I will stress we need to measure the level of macronutrients, the level of micronutrients. I'm going to tell you about these terms later on, pH, EC, and so on. Now, why aquaponics? Okay, because the water quality from aquaculture is poor. It can cause pollution. We use that water to grow the plants. Plants and bacteria, they clean the water, they filter the water, they purify the water, and we return it to the aquaculture pond. So it's a recirculating system. Fish are beneficial to plants, plants are beneficial to fish. It is an integrated farming system. Okay, so we have many advantages which we are going to see. When we do aquaponics, there is efficient water use. You will be surprised. When we talk about hydroponics and aquaponics, people believe, you're using a lot of water. It's not true. It's a system where you have very efficient water use. Why? Because you recirculate the water. I will do one analogy here. On fait une petite comparaison. Bien souvent, nous pensons quand quelqu'un a une piscine, alors il gaspille beaucoup de l'eau. En fait, là où on a une piscine, de l'eau là, il reste dedans, il reste recirculé, filtré et purifié. So it's the same principle over here in aquaponics. The water is there. It is just recirculated, purified, filtered, cleaned, and returned back. The only loss that you have is by evaporation to the atmosphere. So it's very efficient use. So it's one of the ways to save water. You save more water by doing aquaponics than by doing open field agriculture. If you're doing open field agriculture, culture plein champ, so over there you waste much more water than in aquaponics. Now, why is this system? You make efficient nutrient use. Now, why I'm laying emphasis on efficient water use, efficient nutrient use? Because the whole idea of getting IoT, of getting sensors in agriculture is to save on resources. That's the idea of having it. We do it with precision. That's why we talk about precision agriculture. We do it with precision and we save resources. Resources in many terms, in terms of fertilizers, in terms of water, in terms of labor, just to mention a few. And moreover, you have reduced environmental impact. Okay, so you dump less to the environment. When you do open field agriculture, even when you do organic farming, if there is heavy rainfall, all the nutrients are washed and they go back to the soil environment, or deep into the soil or in water bodies. So we have to bear this in mind. So aquaponics is basically a technique where you apply ecological and biological approaches to do fish farming and plant production. So how it works, very quickly. So I have a diagram here. You can read it several times. So fish are fed. Okay, we provide them with feed, not food. It's a mistake here. And excreta, urine, contain ammonia. So you have a lot of ammonia in the water. So what we have in the ecosystem here, in the ecology, we have bacteria, two types of bacteria. So the bacteria breaks the ammonia, produce nitrite, and another bacteria break nitrite and produce nitrate. And nitrate is interesting for the plant because it is fertilizer, it is mineral, it is nutrient for the plant. So the plant uses nitrate, removes the nitrate from the water. Okay, there is a lot of purification being done by the plant root system. So when the water has been filtered, it has been purified, we return it back to the fish pond, to the fish tank. Okay, now definitely in such a system, the oxygen level is important, the pH is important, electrical conductivity is important, and other parameters are important. And this is where you can bring in your sensors and you can automate this system. Okay, you can really automate the system where we don't need labor to operate it. Maybe once a week, you will just go there and see whether everything is functioning properly. Even for feeding the fish, we have solar-powered feeders. Solar-powered feeders for feeding the fish, okay? We can have solar-powered pumps in the system to recirculate the water and so on. So it can become really an autonomous system. In US, there are a couple of farms that are doing aquaponics at very large scale. And it's basically operating with just 1 or 2 people for one whole farm. So that's very interesting where we save labor. The same explanation here. Here I have used more pictures. So just to remind you the principle. So excreta, urine from the fish, contain ammonia. Ammonia is converted to nitrite, which is toxic to the fish. Nitrite is toxic. Ammonia is toxic. So we have to detoxify that ammonia and nitrite, converting it to nitrate. Okay, and that nitrate goes to the plants. You get your salad. Okay, you get vegetable to eat, food for health. Okay, in the root system, you're going to have worm. Worm is natural there. They also eat remaining food waste, so that you don't have a lot of feed waste that is going to produce ammonia. So they are important in the ecosystem. And the water after filtration and purification is returned to the fish tank. So you no longer have ammonia, you no longer have nitrite, it has been filtered, so good water quality for the fish. So at the end of the day, the fish are happy, the plants are happy, the bacteria are happy, and we are happy also. We human beings are happy because we get food for protein, we get, food for growth, that is protein, we get food for health, that is our vegetable, plenty of vitamins, minerals, and antioxidants. So we are happy for our health. Now, these are the key parameters. So that's why I have linked, farming system to crop requirements, to parameters. They're all interlinked. So these are the parameters. Okay. Now, for each parameter, we have an appropriate range. Okay. So what is the level of ammonia we need? What is the level of nitrite we need? What is the level of nitrate that a system should have? For example, for nitrate, it should be between 5 to 150 ppm. For nitrate, it should be between 5 to 150 ppm. Now you'll ask me, what is ppm? ppm is parts per million. ppm is parts per million, okay? And that part per million is 1 milligram per liter. That is 1 ppm equals to 1 milligram per liter. So these are units. We take ammonia, for example, it should be less than 1 ppm basically in the system. Okay, so we do have these parameters and they have certain values that we have to respect. pH, for example, very important. Okay. The system is complex. The pH for fish, the pH for plants, and the pH for bacteria, they are somehow slightly different. The optimum pH for plant, optimum pH for fish, optimum pH for bacteria, they are different, they vary. But here we have to look for a compromise. Like we have a pH, for example, 6.8 to 7.4, that would be good for everything there. 6.8 to 7.4 would be good for the bacteria, would be good for the fish, would be good for the plants. Okay, so this is how we operate. And these are the things that you need to know if you want to calibrate your sensors of the world. You want to calibrate your system and to get it to work, which you will not do, of course, but you need to know that these things are going to come after your proof of concept. Okay, maybe when you're presenting your project, people may ask you whether this is really feasible and whether it is going to work. Okay, so the other parameters are there. Fortunately, we do have sensors for all these. Okay, we do have sensors, they are available, fortunately. Okay, so that's the first part when we talk about, the farming system, and I link it to the parameters. Now we'll go a little bit into the science behind plant production. Okay, I will skip a few slides here because you people, you have been through science education, you have done biology at Form 3 level, science at Form 3 level, you have done maybe biology at O level. So you know a little bit of that. So I will touch base and just remind you of certain principles. So what plants need? Processes like photosynthesis, respiration, and transpiration. We need to know about their requirements also. We'll come to the requirements. And there are 3 groups of factors: climate factors, soil factors, and factors in the biotic environment, pest, diseases, and so on. All these are important if we are talking about farming, if we are talking about plants. Okay, very important. The basics is good. Let's take plant as a factory, like illustrated in my diagram here. We take the plant as a factory. So for a factory, you have raw materials, you have output. Okay, so the raw materials are the plant needs: sunlight, water, carbon dioxide, chlorophyll. Okay, processes that are involved: PRT. You remember the equation for simple interest in maths? Okay, so PRT, simple interest, is called PRT. So here we have PRT, but not simple interest. It is photosynthesis, respiration, and transpiration. They work together, and all the 3 are important for good growth of the plant. Okay, we are going to define them very quickly. Okay, and as output, we have plants' food. That plant's food can become fodder for animal, and animal provide us with eggs, with meat, with milk, and so on. Okay, or we can consume plant's food directly. So basically, they are the primary producers, and they are so important for our food and feed for animals. And by the way, oxygen is given as a byproduct, and which is very important for us. So photosynthesis, you know what it is about. It is about producing carbohydrate, and carbohydrate is stored chemical energy. That carbohydrate is produced from carbon dioxide from the air, water, you know that. Okay, very important. The most important process if we want a plant to grow properly, if we want a plant to give us high yield, most important process. But along with that, we have respiration. Respiration, just imagine your breakfast. Why you have breakfast in the morning? Why you take cereals? For energy. Energy during the day. Energy for all your daily activities. So respiration there is for energy, for all plant activities. If you don't have release of energy, if you don't have release of energy for the plant can't even take water. No energy, no uptake of water. As simple as that. So energy is important for all the activities of the plant. Next is transpiration. Here we talk about loss of water. Now we ask why the plant should lose water. The plant should lose water for many reasons, but two most important reasons is for cooling the plant. If there is no flow of water in the plant system, the temperature will be very high and it will kill all enzyme systems. You know, enzymes are proteins in nature. So if you are going to get temperature exceeding 40 degrees Celsius, you are going to kill all the enzymes. This is number one. And secondly, when you have the flow of water from the soil to the leaf, to the atmosphere, it's a way that you carry the minerals from the soil to different parts of the plant. Now, today we have focused on hydroponic soilless culture. So forget about soil, let's talk about substrate. Okay. Again, the flow of water from substrate through the plant to the atmosphere, it's a way for the plant to absorb the minerals. Okay. I'm keeping it very simple. Next. A very important equation is net photosynthesis. And that net photosynthesis is photosynthesis minus respiratory losses. So this net photosynthesis is the net primary productivity of the plant. This is what the plant stores in terms of energy. This is what the plant stores for our food or for fodder for the animals. So remember the difference between photosynthesis and respiration, which is said again. Now, this net photosynthesis represents what we call the biological yield. Technical term, vocabulary in agriculture. Don't worry. What it is a whole plant biomass. The higher the value of net photosynthesis, the higher will be the whole plant biomass. You will have a greater mass of roots, greater mass of stem, greater mass of leaves, and so on. So basically, when we do farming, we are interested in this. Increase total photosynthesis and reduce respiration. Okay? So that's the way forward. Why? Because we want high economic yield. We want a profitable system. Okay? And what is economic yield? It is a weight per unit area of land of the edible portion of the crop. If, for example, you are growing beans and you want to harvest kidney beans as a pulse, so the weight of dried kidney beans is your harvest. How much of that you got per meter square? How many kg of dried kidney beans you got per meter square? That's the yield. So that's how we measure the system is working or not. This is one of the terms. There are many, but this is the most important one for you. Now we move to growth requirements quickly. What the plant needs? They need nutrients. I'm going to talk about nutrients. I'm going to talk about pH, why it is important and what pH is important. Water, temperature, light. And for the other two, I will skip it a little bit, otherwise it's going to be too detailed. Nutrients, simple. CHO, carbohydrate. CHO, they are the non-mineral nutrients, and they are taken from carbon dioxide and water. You know that. The major nutrients, what we call the primary macronutrients, are required in large quantities. They are NPK, nitrogen, phosphorus, potassium. You remember that, NPK. Then you have another group of major nutrients, what we call the secondary macronutrients. Here we talk about calcium, magnesium, and sulfur. Okay. And lastly, we have the minor nutrients, the micronutrients. They are required in little amounts, or sometimes we refer to them as the trace elements. We have 7 of them. Okay. And very often we forget about nickel, which is an essential nutrient. Nickel is an essential nutrient. We forget about it. So what are they? Iron, copper, manganese, zinc, boron, nickel, molybdenum. Now, why am I talking about nutrients? About, you know, if you're building a smart hydroponic system, you need to supply these. Of course, you need sensors to measure a few of them. Okay. But apart from that, why we talk about nutrients? The nutrients that the plant absorbs are going to become our nutrients also. We take iron, for example. How do we get it? By eating green vegetable, eating moringa, bread mouron, get iron. Okay. Now, nutrients, plant nutrition has an impact on human nutrition. Very often we just ignore it, but it is very important. If I show you the map from USAID, you have all these areas that are shaded in green, black, or gray. All these countries, they suffer from micronutrient deficiencies. One of the most important, pertinent one is iron deficiency. In so many countries, you have iron deficiency. You have vitamin A deficiency. Okay, maybe these people are not eating enough carrots or eating enough of green vegetables. So the nutrients come from the plants, the nutrients originate from the soil, and they impact our health and our productivity. How do plants uptake water and nutrients? They are illustrated over here. I agree that I'm going a bit fast, but I'm going to share the handout of this PowerPoint with you all so that you can read it again. So this is basically how plants absorb water and minerals. They absorb it by the roots. In fact, it's not the roots that we see. The roots that we can't see, the microscopic roots, are those that absorb water and minerals. Okay, so the root hair cells have a very important role to play in absorbing water and minerals. Here you have more detail on nutrient and water absorption. I will skip it because I already mentioned the important point. Macronutrients are required in large amounts. They are given over here just for you to remember. Each nutrient has its role. Each nutrient has a function. For example, phosphorus is important for development of a strong root system. So later, after this talk, you can read it. So you just can remind yourself about key terms that you learned before. I won't dwell too much on this one. This is the one for micronutrients that are required in small amounts. Okay, and the functions of these micronutrients are given. They are required in very little amount. Sometimes you say, we should not supply them, but bear in mind, nitrogen is that nutrient so important for yield. But if you don't have this small guy here, if you don't have it at all, the plant will not be able to use and assimilate nitrogen. So that's a trick in it. Okay, so we need to provide all the minerals. The next couple of slides tell you about pH. I have made it in colors. I have used diagrams. Very simple. When you see the line faint, thin, means low availability of the nutrient to the plant. Like for example, here at pH 4, very faint line, meaning nitrogen is not available at pH 4. Not available, meaning plant will not absorb it. It's not in a form for plant to be absorbed. When is it that nitrogen will be absorbed by the plant? When the pH is close to 6.8. In fact, at 6.8, if I draw a vertical line down here, you will see that all the nutrients are available. All the nutrients are in a form that can be absorbed by the plant. So that's why we need a range of pH. We need an optimum pH to ensure maximum availability and absorption of all the nutrients. This is explained in the next slide. I will repeat myself if I state it. Okay. And I have a pictorial diagram here to summarize what I said. We need an optimum pH for growth of plants. And that optimum pH is from very slightly acidic to neutral. Okay, so that pH range in general is between 5.8 to 6.8. Okay, so very often I use 6.8 as a reference point. Okay, for aquaponics, for example, I use 6.8 because that would be moderately good for the bacteria and good for the fish. Okay, so very important monitoring of pH. The next requirement is about water. Water is a main constituent in fruits and vegetables. Okay? And water is a main limiting factor when we talk about crop production in the tropics. And when we talk about water, it is both quality of water and quantity of water. One aspect of quality of water is salinity. If you have high salinity, good quality of water for agriculture. Now, what do agronomists do? What do irrigation engineers do? They calculate how much water the plant needs. They use equations, they use data, they use constants, they use variables. It's a complex equation, the Penman-Monti equation. It's a complex equation, and they use it to calculate crop water requirement. I've just relate a small story. If you see a guy taking a hose connected to a tap and, watering, he's watering the plant. This is not irrigation. Irrigation is when you provide water, the right amount of water at the right time to the plant. Now, in general, you need so much water per day. Okay, good. Critical periods of water use in vegetable crops are there. Now, I try to give you parameters. If, for example, someone is doing a smart farming project and he wants to save water, he's going to use a soil moisture sensor or a substrate moisture sensor. Now, those sensors, they use units. Okay, they know about, they know about kilopascal or centibars. For example, here we are talking about the soil matrix potential. Okay, so the sensors, they speak this language of water potential. So we need these values if we want to calibrate those sensors. So that would be further information for you for your further studies, that you need this interaction with people who know about water potential. Keep it as a reference. Now, next point is about temperature. When we grow crops, we need to provide the optimum temperature. Okay. Why is optimum temperature? The optimum temperature, which is indicated by T note here, it's a temperature at which you are going to have maximum rate of photosynthesis. This is where you are going to have maximum crop rate. So it's a very important parameter to monitor. Okay, so if you are, for example, developing a smart farming project where you are controlling, optimizing temperature in a greenhouse so that you have optimum growth of plants, so these values are going to be very important to you. Different crops, they have different optimum values, and they are given here. You keep it as a reference. Now, if you are not abiding to the optimal temperature range, you're going to extreme, like too low temperature, too high temperature, you're going to damage the crop. You're going to have freezing injury, chilling injury, heat injury, and so on. Here is a slide where I talk about the detrimental effects of high temperature on vegetable crop production. Okay, so that's about temperature. Next is about light. I have given you basic facts. Okay, what is light intensity under different situations? If you are under moonlight, what is the light intensity? If you are in a lab with fluorescent lamp, what is the light intensity? What is the light intensity when you are under bright sunny day? Light intensity is very important for crop cultivation. If you are doing container farming, vertical farming, you can't mimic sunlight. If you have to mimic sunlight, it is going to consume a lot of energy. It is not going to be productive. So in these modern farming systems, we use only around 1/10 of full sunlight. Let me show you. So this is a graph where I plot like photosynthetic rate against light intensity. Okay, as I increase light intensity, photosynthesis increases. And do you see my red arrow here? Here is a point. This is a light intensity that you're going to provide in container farming or vertical farming system. Okay, as a reference point. Okay, If you want to know about the optimum range for light intensity, it is given in this graph. Different crops, they have different light requirements. This is listed here in this table. Next, when we talk about farming system, container farming, vertical farming, mind you, you're doing it in a building, you are doing it in a container, you don't have sunlight. So what do you do? If you want to grow crops in a room, for example, what do you do? Over there, you don't use high intensity discharge lamps because they consume a lot of electricity. So there are two LED lamps that you use, the red and the blue one, as illustrated here. Why? Because the chlorophyll A and B, they absorb more of the red and blue light, like the scientific evidence given over here. Okay, so this is almost the end of parameters and so on. I know I'm taking a lot of your time, but it is so many subjects, so many disciplines. So I'm trying my best to give you most of it. Okay, so next about the phases of growth. So you know about the vegetative phase and the reproductive phase. During vegetative phase, they produce mostly leaf. Reproductive phase, they produce more on flowers, fruits, and so on. Why I said so? Because crop requirements vary with stages of crop growth. Okay. Now, just a gift for you. I've given you parameters it's almost optimized for hydroponics tomato culture. Have given you the values for temperature, for pH, for substrate moisture content, which you can use. Now we come to the takeaway lessons. So these are the areas where you have, more projects, more funding, and more interest among researchers around the world. So climate smart agriculture, addressing climate change issues, land-based aquaculture, aquaponics, soil health management, precision agriculture. So these are the areas that are attracting more funding, like sustainable food systems, very important, how we reduce food loss and food waste, food safety, very important. These are the challenges being faced by the agricultural sector. I will leave it to you to read. So a very important point, especially after the pandemic, I think we need to be more food secure. And a lot of people are talking about household food security. And how can we reach that by adopting urban and peri-urban farming systems? So maybe with your ideas of small farming system using IoT, using sensors, you can come up with small, proposals that people can adopt in their home place to grow crops for their own consumption, because it is very important that we eat what we produce and produce what we eat. Okay, so on this, thank you very much. Okay, thank you for listening to me. Thank you for being so patient to bear with me, so many slides, and together we grow. And if the chairperson allow, I invite you for question and answers. So thank you for listening once again.
Thank you very much, sir. This was very insightful, and I'm sure so many of our students have benefit so much of your knowledge, because whole of your slides were so informative. I'm sure they have got the required knowledge and resources to perform well in our implementation day. So thank you very much for that. So we will now start.
Is mine, Sanya.
Shania.
Shania.
So we will now proceed to our Q&A session. Feel free to ask any questions in the chat box. Where we have a question. Where can we get more information about the optimum composition of the minerals which vegetable use? For example, you gave a composition for tomatoes.
Yeah, it's a very interesting question. In fact, you can get it from the internet, from certain companies that post this information. But many many big businesses, they keep it as a secret, because if they are successful with a particular crop and they have a secret of the recipe, or if you want secret for the protocol to grow that crop successfully, they're not going to share. But such information, you can derive it from textbook. You have textbook on hydroponics, you have textbook on nutriculture. So from these textbooks, you have the protocols that are given. Now, many times what happens, we use a general formula, and when we try it at our level, we grow the crop out at our level, we do some fine tuning. So we learn from ourselves. So you can always start with a generic formula, and you can optimize for the particular crops that you're growing. Okay, that's if you have a new crop species that you want to exploit. But if you are growing lettuce, if you are growing strawberries, if you are growing tomato, for these crops, you have plenty of information on the internet. You just have to type nutrient solution for tomato culture or nutriculture for hydroponics tomato cultivation. You just play with, play with the keywords. You will go there, you will get this information on the internet and textbook.
All right, thank you very much. So another question. Do you know about any projects using IoT in agriculture in Mauritius or any companies?
Yes. There are not many. We can count on fingers because this is new. Using sensors, using these PCBs, calibrating them, the knowledge that you need, the electronic side, and sometimes if you want to go even further, programming, all this costs money. And because of that, adoption of the technology is slow. But certain farms, I know one that I visited, I won't give the name of the owner, it is in Solferino, and there's one in Bassin, okay? They have used, an integrated system for hydroponics, meaning for their hydroponics, they don't have to measure pH and EC and measure, the content of different nutrients from time to time. Usually, a hydroponic entrepreneur have to do it 2 or 3 times per week. So what they have done, they have automated it. And how they have automated it is by the use of IoT and sensors. So they have a small device where you have the sensors, the PCBs, you have everything there, the relay switch, etc., the connection wires, the jump wires, and so on. It's all there. And automatically, this device is, controlling the system. So hydroponics is automated. So it's being done little by little. And I know someone who is importing these kits for farmers. It's quite expensive. You need to keep around 100,000 rupees. That was 2 years ago, 100,000 rupees to buy that kit where you automate your hydroponic system. So the pH is controlled automatically, the EC is controlled automatically, and so on. I know certain guys who are at experimental level, they're trying to automate the aquaponics, but it's not easy. It's a very challenging system because you have so many species there. So this is also there. IoT is also in irrigation, smart irrigation system. Today itself, I've seen a small kit where you have a smart misting system. When you do anthurium production, you have to mist the shade house. Or when you do seedling production, small plant production, you have to mist the greenhouse. So you have an automatic, an automatic misting system, which is a smart one based on the use of sensors. Now, similarly, certain irrigation engineers, okay, together with the private sector, they are working on smart irrigation system. Why smart irrigation system? They have a soil sensor. The soil sensor is connected to your board. You have all the setup of IoT. You have a SIM card there, which can download meteo data. So automatically, this is irrigating the crops and cutting the irrigation when there is enough water. I repeat, when it is dry, the irrigation system is on. How we know it is dry? The sensor senses it is dry. okay, based on value of water potential, which I said in KPA, in centibars, and so on. And when there is enough water, when it is moist enough, okay, it cut off the irrigation supply. So these are certain applications that I came to know informally, at local level. But internationally, like for example, in Reunion Island, they are using the smart irrigation a lot. Okay, in fact, I learned it there. Even for irrigating sugarcane, they have smart irrigation system, and they have the drip system, and they have SIM card in the irrigation controller, and the SIM card is connected to the mobile phone. The SIM card is connected to the internet, and downloading data and so on, METS data and so on. So this is how it works.
All right, thank you very much. That was very interesting. I have another question. What is the recommended flow of water for the plants in controlled environment you presented in the slides?
What is that?
Recommended flow of water for the plants you presented
Okay.
in the slides.
The recommended flow of water, it would be in liters per hour. I don't have it here in my brain. I really didn't think about the flow rate. Okay, so I can find this out and give you the information. It is not in my brain. It is a figure.
Yeah,
You can understand. I can't remember everything.
yeah,
Definitely.
it's all right.
You have a flow rate in hydroponic system.
We have another question in the chat box. So is there anyone who has implemented any setup of IoT or any latest technology to control temperature in greenhouses?
Not to my knowledge in Mauritius. And it is a very interesting point that you raised. Temperature is a major limiting factor, in agriculture locally. All the greenhouses, they have problem with temperatures because we have temperature extreme in summer. And mind you, temperatures in greenhouses can reach above 40 degrees Celsius. In some places, 45 degrees Celsius during the day. So it's very high time that we have, this IoT system, a system of sensors where we can control temperature. So where we can open the ventilators, where we can operate the fans, or when we can operate the misting or fogging system to cool down the greenhouse. So if we do it automatically, it is going to be a marvelous project. So congratulations for bringing this idea up.
Well, that's really nice. I have another question related to project itself. So if we build a small system, can we get incentives and release it on the market? Are there any incentives for building and implementing small systems?
Not yet to my knowledge, but if really
Okay.
people are interested in smart farming projects, I think next year or the year after, we can just, throw this idea to the Minister of Finance, and they can develop schemes with the Development Bank of Mauritius to provide, financial incentives or other kind of motivation for people to embark on smart farming system. But to now, up to date, we are still researching. We are still trying to find our way out. I'm talking about Mauritius. Okay, we are still finding our way out. In other countries, in US, they are using it currently, but here it is still being researched. And we have not yet come up with a model that is really workable, that is feasible, and that has an impact, on farmers, where farmers will be interested to buy those kits. Okay, we have not reached that level. We are still researching. And I think it is going to take time. But if it really happens that we have a lot of ideas, we have a lot of kits that are smart, that can be used in farming, I think we have to throw it to the mind of the ministers, and they can create fiscal incentives via the DBM bank and help farmers. Why not? That would be lovable to have.
Yes, we have another question in the chat.
Mhm.
Is there a specific time that the plants absorb nutrients, and should the
Mhm. Yeah.
well,
Yeah, actually, plants absorb nutrients. I got the question. Actually, plants absorb nutrients during the day. During the day where you have, sunlight, where you have evapotranspiration, this is a time when they absorb nutrients. At night, you should not, supply nutrients. In fact, you should not be circulating nutrients because you don't have any evapotranspiration. So there is no pathway for the plant to absorb nutrients. Was that okay?
Yes, it is. Thank
Yeah,
you.
the nutrients should be supplied during the day when you have sunlight.
Yeah.
Any other question?
Another question. So, following the temperature issues, especially in the North region, being a tomato hydroponic grower, is there any setup or kit which would be efficient for now to use to control the temperature following a rise of plant issues, causing like blossom and rot and so on?
Yeah. Okay. When it's good that you brought this temperature, and quickly I bring my slide on temperature for tomato. So you have temperature, you have at two levels, aerial in the air, and temperature you have for the substrate. So as far as possible, you have to be within those range. Okay. And how to get it within those range? This is where the sensors would be very useful, because manually it is impossible to monitor the temperature hourly, daily, and so on. But with sensors, it can be automatically done, and you can activate certain systems to correct the temperature, like fogging system, misting system, fan and pad cooling systems. There are so many techniques to cool the greenhouse that can be activated by a whole network, by an architecture of sensors, platforms, microcontroller boards, and so on. So that would be very, very useful. And it's a very interesting project. Yeah, if someone mounts something on it, it is really laudable. Okay. But up to now, I have not seen anybody doing it.
Yeah, well, we have so many questions. Shows how many people got so interested in your presentation. Well, I will take one last question. Actually, the question on absorbing nutrients and the specific time. It continues. It said, should the cocoa bags always be moist throughout the day?
Okay. Actually, when we do hydroponics, we don't allow the water every second. Okay. So when we do hydroponics, we allow the water once or twice per hour. Once or twice per hour. Meaning, if once we have activated it for, let's say, 1 minute, okay, so the remaining 30 minutes, 30 minus 1, the water is not being applied. It allows the cocoa beet to dry, to drain. So what we do, we apply water, we allow it to drain. We apply water, we allow it to drain. This gives you a very interesting idea. How can we save energy by the use of sensors and optimally provide the nutrient solution to the cocoa bag? You have a cocoa bag where you're growing your plants. So if you're clever enough, so now let's develop a system where we are not going to, activate the pump twice an hour. We'll activate the pump only when the plant lacks water. And how do we know that the plant lacks water? Is by having a soil sensor over there. Okay, I have given you some values. It is on one of the slides where I have given you the soil moisture content in percentage and soil moisture content in kilopascal or centibars. So these are the values that you need to look at. If you know for a particular crop, you can dry it to that extent. You wait and dry it to that extent. When you reach that level, your sensor activates the pump, then you supply the water. You're going to save cost of energy. You're going to save water. you're going to save a lot of resources and reduce cost of production. So this is where the sensors come into play to do things optimally. Only when the plant needs it, you give it the right amount of water. Nothing surplus, nothing less. This is the optimum use of resources, and this can only be done when we integrate sensors in farming. Very interesting question.
All right, thank you very much, sir. It was very, very interesting. I'm sure so many of our students got so much knowledge from you. Thank you for sharing your expertise with us.
Yeah, thank you. The pleasure was mine. If you learn a little something from me, I'm very happy, and share it with many people, because I'm very keen to see a future for agriculture. I want to see agriculture being more innovative, being more technology oriented. Okay, I would be glad to see more and more engineers, having an interest in farming. Real pleasure to be with you tonight.
Well, sir, I think there may be some of our students who would like to stay in touch and maybe ask more questions. If you would like to, please share your email address in the chat box, and we can contact you, because I feel
you
still.
can add me to Classroom.
Yeah, we will add you to
Then
the
if there are questions, when I have time, when I'm free,
Mhm.
I can answer those questions. That would be the easiest way to do it.
Yeah, it's good.
Great.
Thank you. Yeah, thank you very much, sir. I will
Wonderful.
move
Thank you.
Yeah, thank you.
Thank you to you, the host, for hosting me. Thank you to the organizers. And thank you for all these brilliant students who are thinking to help agriculture, to help farming, and to help the community at large, meaning our local population. Thank you for that.
We are grateful, sir. Now, if you could please stop sharing, we will now move to the last bit of our webinar today. So once again, thanks a lot to Mr. Navindra Budia, to Ms. Pooja Sinod, all the executive members of IEEE, and the organizing team, because without them, these webinars wouldn't have been a success. And obviously you, the audience, because it's with you that we keep pushing and moving. So I will actually give a small, very small, just bear with me for a couple of minutes. I won't take much of the time. A small PowerPoint presentation on my experience in the IEEE Society, because it's really nice to have active societies in our universities, and we are really able to express ourselves and develop other parts of ourselves that we didn't know we had. So let's start. So Shanya's IEEE experience so far. So now that we have come nearly to the end, let me share my experience. Well, how it all started. It all started, well, on recruitment day at the start of December last year. The executive members of the society organized a fun team building session, I will say, with games and quizzes, and where the winners would eventually get goodie bags. So additionally, the students, meaning the executive, also did a fun little random number generator whereby the one who will be picked will be given a free subscription to IEEE for a year. And I got chosen by the random number generator. So I must say it was God's plan. Well, so here came the day of our first meet and greet. As you can see, this is me, so stressed out. And you can see that my body language is very stiff. Mentally, I was like, oh God, so many people are watching me. And this was only the meet and greet. I had only to introduce myself, and that was it. So I was stressed out this little bit. And you can see the body language, it's not good at all. But then after that, eventually, we evolve and things change. So after IEEE, it's now been, well, 10 months, we have created memories. So as you can see here, I was the MC for our first seminar of 2022, along with my friend Ashley here. It was not perfect, but hey, major improvements were seen in my voice tone, my posture. And I need to point out that apart from building those soft skills like leadership skills, time management, being in a society, uh, not only builds teamwork, but also we build a network and eventually get great friends at the end of this great adventure. So more of the journey. Here we kind of see the evolution. This was for International Women in Engineering Day, INWED for short, where I have led the project of going to a high school to empower and inspire young girls to think engineering as their future degree and how engineering is so important in today's society. So as you can see here, we had a large audience and so many positive feedbacks and responses. This event was definitely a success, but you know, we had really few time to prepare on it, but it was such a huge success, I would say, because despite all this, all the ups and downs, we always make it work, and that's what teamwork is about. So as you can see, you can see a major change between here and here, definitely. And this, what I actually did basically. Well, I'm very glad I got the opportunity to speak to you all today, and I'm sure it will not be the first time. I really hope to see many of you soon in our IEEE student branch, because you know recruitment will be starting soon also, and because this society is for students by students. So here's to achieving all our goals and dreams, however big or small. Thank you very much for your kind attention. So I think Yashil will now will say some few words. Yashil, if you could please unmute yourself.
Yes, thank you, Shania. Well,
Welcome.
actually, I was not planning to talk today, but how can I actually not thank Mr. Bujal? I remember actually when we had meetings, we were still discussing about things that should be covered because agriculture is really quite dense. And I can say that today mission accomplished. So thank you very much for that, sir. We can see the amount of hard work you put into the slides, very insightful, lots of information, and I'm sure that all the students really loved it. And thank you very much for your generosity, actually, for sharing all these with us and for your time and for overcoming the small issues that we encountered along the road. And I just have one small question, if I'm allowed to ask you. Well, actually, we are talking about closed system in agriculture. We are talking about greenhouses, etc. But we can still see that people are going for open area agriculture, if I can use the term. But well, I did some research and found out that when we use a closed system, we have issues, for example, to maintain the proper atmosphere, consume lots of power. I think that these are some of the challenges that we encounter as engineers when implementing everything. We also have diseases that spread faster in greenhouses compared to open area agriculture. But do we have other factors that might advantage the farmers who are using open area?
Yeah, it's a very nice question. And actually, you know, in this agricultural landscape, both should exist. The open field agriculture and what we call sheltered farming. Both should exist. Sheltered farming mostly for, you know, high value crops, for the vegetables, for the fruits, and so on. And open field agriculture mostly for the cereals, pulses, and so on, and other crops. So both should exist. They, in fact, should coexist. coexist while even with regard to inputs for open field agriculture, we use greenhouses. Most of the seedlings now being used in open field agriculture are coming from greenhouses. So people in greenhouses are specialized to produce the seedlings that are sold to farmers in open field agriculture. So they are there, they will exist, they will coexist. Now, there is nothing as such, both have their advantages and disadvantages. In fact, in life, everything has advantage and disadvantage. So I won't be able to answer it with, extreme precision in terms of how, one system outcompetes the other or how the other system outcompetes this one. It won't be fair to both of them because both of them are important for our survival. But if you want something very specific for me to answer, I will try to give my best.
Yes, so thank you very much. And again,
You want
thank
something
you for
else?
your
You were
dedication.
expecting something else in terms of answer?
No, it's okay.
It's okay. It's
Yes.
okay.
Yes, and I said the whole presentation really insightful. I'll definitely rewatch everything, the slides, etc. Because there's definitely lots of knowledge out there that thanks to you, actually, I am more we can say familiar to some of the shadowy parts of agriculture.
Yeah, it's really a pleasure for me tonight, talking to so many people who has interest in agriculture. I thank you all, the members of the organizing team for giving me this opportunity, and thank also to my dean for nominating me, to be a resource person for this webinar. I think you can send him, a thank you note saying that how it went on, so that he knows that the work has been done. So work has been dusted. Okay, good, Yashil. So thank you once again, and it was my pleasure to share my knowledge with you.
Thanks, and definitely will invite you for the competition. You can see our students, what those approaches that the students are doing.
That would be great to see what the ideas you picked up. Wonderful.
So thank you very much.
So I take leave now. Okay, good.
Thank you. Goodbye.
Bye-bye. Bye, everybody.
Goodbye.
Bye,
Thank you
sir.
very much.
Thank you.
Bye, sir.
Bom, guys, só um présentation super, super.